Okay, section 2.4, part 4, and the fourth type of chemical reaction. So the fourth type of chemical reaction is the double replacement reaction. Okay, so double replacement reactions swap elements between two compounds that react together to form two new compounds. Okay, so double replacement reactions swap elements between two compounds reacting together to form two new compounds. So let's see what that looks like. Okay, so elements are basically switching places between the original compounds when the two compounds react. You will know that this has taken place because the two solutions react to form a precipitate, sometimes abbreviated as PPT, not the PowerPoint. Precipitate is a fancy way of saying it's a solid that's formed, and another solution. So this is something we've seen. We saw this in our ionic compounds lab, where you created 12 different precipitates. We've seen it in the demo that I did with the potassium iodide and the lead 2 nitrate, producing the really yellow solution, the yellow precipitate in solution. So it is something we've seen quite a bit already. Okay. So the way that you know the reaction is taking place is that you start with an ionic solution plus an ionic solution, and then you end up with an ionic solution plus an ionic solid. If you don't get a solid, or like a gas or something formed, it's really hard to tell that this reaction has taken place. Okay, if everything just stays in solution, then we say there was no reaction. Okay, so AB plus CD gives AD plus CB. So important to note that the metals at the beginning stay as the metals at the beginning. So A and C have been designated as metals because they're listed first in the ionic compounds. And then B and D would be the non-metals. And there's what's switching places here. So if potassium chromate and silver nitrate react, they form a red precipitate known as silver chromate in a solution of potassium nitrate. Okay, so that's what that looks like. We had one, I was going to say very similar to this. I think we actually had this reaction take place in our ionic compounds lab. So potassium chromate, K2CrO4, and silver nitrate, AgNO3, and when they react, you get Ag2CrO4 and then KNO3. So the potassium was paired with the chromate. At the end, the potassium is paired with the nitrate. Silver was paired with the nitrate, and now the silver is paired with the chromate. Okay, so they are switching places. Okay, so this is basically starting with two couples and then having them both switch partners, so even more scandalous than the single replacement reaction. Once again, a little bit of practice to do.